In this problem, we're told that the marketing research department estimated the sales in millions of dollars to be increasing according to the formula S prime of t equals 4 e to the minus 0.08 t, where t is the number of months after the introduction of a new car, and the total sales function is S of t, and they said assume that there would be no sales. I guess that's a safe assumption at time 0. To find the sales function in this case, we're going to need to anti-differentiate the derivative. The antiderivative of the derivative is the function itself, so we're going to need to integrate 4 e to the minus 0.08 t dt, and we'll get back a set of functions from this, the set of antiderivatives. The plus c that we'll add on here will distinguish one function from the next. So we actually need to find the sales function that has the given derivative but also the given function value. We need no sales at time 0. So this in the end is going to determine for us the value of plus c, the c that we add on. So now we can concentrate just on the integral. The 4 is no big deal. Antiderivative of an exponential is easy if the exponent is simply the variable we're integrating with respect to. In this case, it's a bit more. You might be able to guess and check your way to the solution of this one, but I'll walk through the substitution process just in case you can't see the guess. I'll let u be the exponent. That's the inside on a chain rule. So it's a good rule of thumb. If you've got an exponential in the problem, you might try the exponent for u. du is always a calculation. Take the derivative of u, in this case that's minus 0.08, and then add on, multiply by a dt. And then attempt to rebuild your integral. Now again, part of this is easy. The u came from this exponent, so there's going to be an e to the u in the problem. What we've got to cover here is a 4 dt. The dt can be found here. I need to have a 4 dt in my problem. So there's a couple ways to go about this. We could solve for the dt here and put that in and just leave the 4 in there. That technique's probably going to be the simplest in this case. So I'm just going to leave the 4 in there, and this dt will, if I solve for it, be equal to a 1 over minus 0.08 du. Since I had to solve for dt in this case, do a little algebra. This is what I would call a type 2 integral. A little bit of algebra right here, but we did not need to return to the u line, so it's not a type 3. I'll now place the dt back into the problem by writing a 1 over negative 0.08 du. And I'll clean this up. There's a constant, 4 divided by minus 0.08, which is the number negative 50. And I've got an e to the u du. Anti-differentiating now is pretty straightforward. Pull a constant out of the way. Integral of e to the u is e to the u, and then I'll add on my constant plus c. To finish this portion of the problem, I'll now return to t and find that our sales function must be one of these, minus 50 e to the minus 0.08 t plus c. And again, we need s of 0 to be 0. So if I plug 0 in, s of 0, and check to see what I get minus 50 e to the 0 plus c. E to the 0 is the number 1, so this is minus 50 plus c, and I need this is what I need to have happen. I need this to be 0. So the only value of c that'll make that happen, solve for it, you get c equals 50. So I've concluded that my sales function must be minus 50 e to the minus 0.08 t plus C, which is 50, plus 50. That is my sales function. And again, to check this will require two steps. One, I will take the derivative, make sure I get the derivative that was given in the problem, and the other I'll plug in 0 and make sure that I get out 0. So my check's down here.